Hi, this is Nikos Petrelis, and this is the first video of the playlist microcontrollers course, which is the laboratory based on STM32 F4 Discovery development system. We start by introducing the Keil Microvision Tool, which we assume that is already installed. So I open the Microvision tool. You can see my notes in the screen right now. Keil Microvision, this is here, Microvision 5. So the first thing we will get when we install the Microvision tool is the package installer, which we can open also from this icon here. In the package installer, we have to select once the board we are using and install the necessary drivers. We move to the board's frame and find the STM32 Discovery. F4 Discovery, this one here, revision C1. And then we go to the next tab here, and under device specific, we have to make sure that we have installed all this package here, DFP, which, as we can see, concerns device support, drivers, and examples. You would do install if you have not already installed it. I have already installed it, so it says it's up to date. So I'm okay from here. And then as a next step, I have to create a new project. New Microvision project. We go wherever we like to do this. The one I have created is called Blink LED. It's already here, but I will create a new one, Blink LED 1, let's call it. If we have already installed the STM package from package installer before, we will see an option here. So from this tree, we open and try to find the STM32 407. This matches my development board. And this one here, 407 VG, and the one underneath this, VGTX. So I select it and press OK. I have to fix some issues here. First of all, in the management runtime environment card that opens here, from the board support, I have to find my board, STM32 F4 Discovery. Here it is. Then the next I have to do is to select from CMSIS the core package. And from the device, I open it, I select the startup, and then from STM32 Cube framework, I select the classic. These three selections have to be done in order to start with my first exercise, which is simply a demonstration of the whole environment, and a software program that we will not describe it in this lab. We will describe it in more detail in the next lab. But I can tell you from this point that it uses GPIO ports. So if we go under the STM32 Cube Hall, first of all, I have to tell you that the Cube MX is an auxiliary software package that we will install it and use it in more advanced projects because it makes easy the software initialization of most of the peripherals that we need. But here, some fundamental configurations have been done, and we can see them under this option here. For the present, we do not see anything, but there are some issues below, as you can see here. and we can press, we can click on the resolve button. And after these issues have been resolved at this point, we see that under the STM32 cube hole that previously nothing was selected, we can see that the common, the Cortex, the GPIO, the power management, and the other fundamental aspects of the microcontroller are now selected. So all of these will be needed for the initialization. So I press OK. Let me see my notes if everything has been done correctly. Okay, we selected this one on the board support. We resolved what was needed. We verified that the fundamental peripherals were already connected. Yes, now it's the point where we have to move to this icon here, options for target, in order to prepare the compiler that is needed, the linker that will be the debug link that will be used in order to connect to the development board, etc. I will show you at the end of this video how we connect the board, but in order to avoid interrupting this presentation of the Microvision tool, we will move directly to the C++ tab, where here we have to define use HAL_driver. I think this is what I have to write there. Yes, use HAL driver. Okay, use HAL driver, and in the include paths I have to define where my project will be. It has to be all of this path here. But I think that since I have already defined this project here, I may simply select, but I can do this from this point, I think. Okay, let's find it. It's the path documents of my drive, Microvision. Yes, this one is here, and this has to be selected. So I just select this one, and I'm okay with this tab. Now, the next and most important is to go to the debug tab, where we will select the link that we will use. The simple USB cable that connects to the mini port of the ST32 Discovery board is the ST-Link debugger. I have to tell you that you have to install already this one. If you have not installed it, you can find it from this link here. So you can pause the screen now and try to find this driver. And then when I connect my my board, as you will see now, if you give me 1 second to unpack the board, okay, and use the appropriate cable. You will see the cable later. Okay, found the right one. So you will see right now that when I will connect it, we will get an icon at the bottom right. Okay. If you connect it at the first time, you will see at this frame here that it tries to install anything additional needed about the driver. But I have already installed it, so if I am okay with my driver and I go to the settings, I will see some I will see that it recognized some things here, but here I was expecting to find. Let's see if I disconnected and connected again, if I will get the same message. I disconnected it right now and I connect it again. So let me see right now if something different will be presented. I still get a communication error, but let's see if we can fix it. However, I see that here the memory space that will be needed to download my program to the flash memory is recognized correctly. So I guess that maybe it's okay, but we will see in the process. Okay, I press this button, the window goes away, and now I have to put my code here. These are initialization files that have been installed and have been included in my project, and now my own files have to be placed here under source code 1. So with right click here, I add new item, and it's a simple C file that I will use. I will call it main C. I just type the word main. No. Well, it will place it in a directory where I have already some different projects. So let's call this one a slightly different name. Add new item. Let's call it main 1. Okay, and I will copy paste my code. I will not explain it here. It will just blink the LEDs, all the 4 LEDs that exist on the STM32 Discovery. Here is the code that I copy. And here it is. So if you can even just pause the screen right now and copy the code, it will be good to type it from scratch, because it will get you familiar with some name formalizations. So this is the code, and what we can do is right away we can build the project if everything is okay, and watch the messages below on the console. So target 1 is built right now. We expect to see the messages. Good, I get 0 errors, so I'm fine. The next thing, since my board is already connected, is to download to the flash. From the flash menu, I select download. Let's see if it will be downloaded well, but I still get this error, so there is indeed some USB error. Okay, so watch out what was the problem with the board that was not recognized earlier. The problem is that when you go to the settings, it does not have to be connected through a JTAG interface, but you should change it to software. If you change it to software, then you get the link recognized, and you get such a message such as the one that you can see here. So everything, it's not important if you get under reset. I think it's normal too, so you can do this. So now, since we have already built our project, let's try to download to the flash. Download. Okay, now it is programmed and it's fine. Now we can start a debug session to see what's going on and if our program works well. So you can see here that at the upper frame you will get the compiled program in the assembly instructions and commands, and at the frame below you will see the original C language. So everything you could do with an advanced simulator or debugger, you can do this here. You can move step by step. You can see the internal registers of the ARM processor. How do they change? What happens to the stack, to the system? You can view memory, anything you like. You can see all these options in the following laboratories. Now I will simply press run, and at the last part of this video you will see my card, the LEDs on my card blinking. This is what my program does. So if I press run, everything runs, and if I press stop, the system stops at the point where the last command was executed. So this is the STM32 board connected with a USB cable to one of my ports. So I will start the debug session, the run option that I did earlier. And as you can see, 4 LEDs all blink together. This was what my program was doing. See you at the next video.